Ion engines sound like something straight out of a science fiction movie, used to propel massive spacecrafts in space. However, they are actually a reality and are currently used on many of the technologies we have today. In this video, we'll go over how rockets work, how ion engines work, and how they compare. Before we dive into the science behind an ion engine, we first need to go over how spacecrafts are able to travel in space in the first place. According to Newton's third law, every force has an equal and opposite reaction. So whenever we jump, we are actually applying this law as we push down into the earth. The same amount of force is able to push us upwards, making us jump. Now we can upscale this to a rocket ship, where we apply a large amount of force towards the earth through burning fuel and creating hot exhaust gas. And since we exerted a large amount of force by pushing the hot exhaust gas into the earth, we will lift up by the same amount of force applied, boosting us into space. So now how does an ion engine compare to this? By using the same law, instead of shooting out hot exhaust gas to give us a forward push, ion engines shoot out ions. Ions are essentially atoms that have more or less electrons than usual. Take sodium for example. Since it is number 11 on the periodic table, it means that sodium atom also has 11 electrons. If a sodium electron is lost, then the sodium atom with 11 electrons becomes a sodium ion with 10 electrons. This is roughly what an ion engine looks like, with the ionization chamber in the middle, some magnets covering the top and bottom, one tube for the electrons, one tube for the propellant, and a neutralizer. In an ion engine, xenon gas is usually used as the propellant, because this element can easily be made into an ion. So xenon atoms are shot into the ionization chamber here. Next, electrons are fired into the same chamber, colliding with the xenon at such a force that it knocks electrons off the xenon atom, converting them into positively charged xenon ions, or cations. The magnets around this chamber create magnetic fields to speed up this ionizing process. Next, the xenon cations are accelerated out of the thruster, giving it the speed boost just like the exhaust gas on a chemical rocket engine. Lastly, a neutralizer nearby the thruster shoots out excess electrons saved up inside the ionization chamber to neutralize the ions shot out and make sure the chamber doesn't become overly negatively charged. If the chamber becomes negatively charged, then the expelled xenon cations will simply circle back into the chamber. So how do ion engines compare to the chemical rocket engines then? Ion engines, even though they are a lot more complicated to build and understand, carry many benefits. The most obvious one being the speed. Chemical rockets can accelerate a spacecraft to around 29,000 km per hour, whereas ion engines can accelerate a spacecraft to around 324,000 km per hour. Furthermore, it is much more efficient, as around 90% of the propellant in an ion engine can be converted into energy propelling a rocket. Only around 35% of the propellant in a chemical rocket engine can be used for propulsion. Lastly, ion engines can last up to 7 to 10 years, whereas a chemical rocket will run out of fuel in under an hour. However, ion thrusters do not work on Earth because there will be ions disturbing the engine, and the thrust generated actually isn't powerful enough to leave Earth. Think of an ion engine as propelling a little bit over a long period of time, whereas chemical rockets propel a lot in a very short period of time. And there we have it. Both chemical rocket engines and ion engines work by pushing out a lot of energy toward one direction, making them propel in the opposite direction as described by Newton's third law. Ion engines are able to propel themselves by shooting out ions accelerated from electrons, hitting them inside the ionizing chamber, creating thrust and pushing the engine forward. I hope that y'all have learned something interesting today. Thank you for watching, and good luck with everything.